All right, so when we're trying to set up a confidence interval, we're going to take our percent that we estimate and we're going to add and subtract the error. So in this first problem, we see that we have a 55% approval with an error of 3%. So if we want to figure out our confidence interval, we're going to take that percent that we have and we're going to subtract the error. That'll give us the lower end. And for the upper end, we take our percent and we add the error. And if we look at that, that would take us to 52% and 58%. If we wanted to write a sentence, what we would say is we are confident the proportion of people who approve the candidate is between 52% and 58%. Now, similar with the second problem asking about students having their parents call about grades, we would take our 12% and our error of 5.2%. So we do 12% minus the 5.2% for our lower level of the proportion, and we'd add them for the upper confidence interval. So if we do this, we'd get to 6.8% and 17.2%. So what this would mean is that we are confident that the proportion of college students who ask their parents to call their professors is between 6.8 and 17.2%. Now, that's when the information is already given to us. What if we have to calculate ourselves? Well, the first thing we'd want to do is calculate our estimated proportion for success and proportion for failure. So if I think about my proportion for success, my p hat, it's always going to be my proportion for success out of the total. So here that's 752 out of 1,002, and that is about 75 hundredths. So then if I want to find my proportion for failure, that would just be 1 minus my p hat value, which in this case is about 25 hundredths. So about 3/4 of people say they recycle and 1/4 say they don't. Now I want to set up my confidence interval. So to do that, I need to find my margin of error. So my error is going to equal my z-score. In this case, because it's 95%, that's going to be a z-score of 1 in 96 hundredths. Do the square root of my p hat value times my q hat value divided by my sample size. In this case, it was 1,002 people. And if I simplify my expression there, I get to about 27 thousandths. So if I want to construct my confidence interval, I would take my 75 hundredths and subtract the 27 thousandths. That would be my lower end. And on the upper end, I would take my 75 hundredths and add the 27 thousandths, which would take me to 723 thousandths on the lower end and 777 thousandths on the upper end. What does that mean? If I want to look at it as percentages, I could say we're 95% confident that the proportion of adults who recycle is between 72.3% and 77.7%. All right, so let's look at the example then with the smokers. So with the 284 smokers, we can say that our p hat is those that are trying to quit. So that would be the 204 out of 284. And this 204 is approximately 718 thousandths, which means that our q hat would be 1 minus that, which is approximately 282,000. So when we want to calculate our error, we know again we're going to use our z-score of 1 in 96 hundredths, square root our p hat times our q hat over our sample size, which in this case, again, 284 people. And this gets us approximately, change these equals to approximately 523 10,000ths. So if I want to think about setting up my confidence intervals, I would take my 718 thousandths minus the 523 10,000ths. That would give me my lower confidence interval. And then my upper would be the sum of 718 thousandths plus 523 10,000ths, which is about 6,657 10,000ths and 7,703 10,000ths. So if I change that from my decimals to an actual percent, I would be saying that we are 95% confident that the proportion of adults who want to quit smoking is between 66 and 57/100% and 77 and 300%. All right, so the last problem was dealing with the traffic congestion. And we had this table showing some different percents, and they want us to go from the beginning and calculate the proportion, the confidence interval for the proportion of people from the east who are concerned about it. So we know that from the east, our p hat is 36/100ths, which means that our q hat would have to be 64/100ths. So we need our error, and that's going to equal, in this case we're doing 99%, so that's 2 and 575 thousandths times the square root of 36/100ths times 64/100ths over our sample size. And our sample size here was 400 adults. And this gives me an error of approximately 618 10,000ths. So if I want to think about my confidence interval, I'd take my 36/100ths, subtract the 618 thousandths, and then I would take my p hat and I would add the 618 10,000ths, which gives me values of 2,982 10,000ths and 4,218 10,000ths. Or if I want to use that in percentages, I'd say we are 99% confident the proportion of adults in the East who say traffic congestion is a serious problem is between 29 and 82/100% and 42 and 18/100%. Now we're going to do a very similar thing to figure out for the South. Again, here we know the South is 32%, so our p hat here is 32/100ths. Our q hat would have to be 68/100ths because we need to add up to 1. Our error we know would be, again, the 2 and 575 thousandths times the p hat times q hat all over, sample size is still 400, and this would give me about 6/100ths. So if I want to calculate my confidence interval, I'll take my p hat, 32/100ths, subtract the 6/100ths, give me my lower bound. My upper bound would be the 32/100ths plus the 6/100ths. So what we have here is that a confidence interval from 26/100ths to 38/100ths. So if I want to write a sentence, what I would say is we're 99% confident the proportion of adults in the South who say traffic congestion is a serious problem is between 26 and 38%. So then the last question asks, is it possible the proportion of adults from the South and from the East who think traffic congestion is a serious problem could be equal? Is it possible for them to be equal? So let's look at these proportions. So we have here that this one So this was the east, and here we have this was the south. So if we look at those two values, the proportion could be anywhere between these two values. If we look, this is about 30% to 42%. This is 26 to 38%. There is a lot of overlap between these two values. So yes, it's possible that they could have the same proportion. So even though the samples weren't the same, if we actually could calculate the literal population proportion, because the intervals overlap, it's possible those proportions could have been the same.